Jocelyn, here's number 26 you asked about. They want you to compare a kilogram to a microgram. Well, the prefix kilo means 1,000. So if you have a kilogram, you have 1,000 grams. You can think of that as 10 to the third. If you have a microgram, you have 10 to the negative sixth grams, or you could think of that as a millionth of a gram. So if you look at the difference between 10 to the third and 10 to the negative sixth, the difference between positive 3 and negative 6 would be 9, right? So a kilogram is basically 10 to the ninth times bigger than a microgram, and that would be 1,000,000,000 times bigger. So I would say a kilogram is 1,000,000,000 times as large as a microgram. I hope that helps. Jocelyn, here's number 47. They asked you to calculate the average power in watts. What I did was I calculated it in joules per second, which is a watt. So I took what they gave me, which was the 150 calories per mile, and I know that I'm going to run a 6-minute mile. And remember, I have to get joules on the top and seconds, which is time, on the bottom to get to a watt. So I went ahead and got rid of the miles by saying 1 mile in 6 minutes. And then I don't want minutes, I actually want seconds, okay? But I know that I'm going to run for an hour, which is 60 minutes, right? And so I put 60 minutes, and in an hour, instead of writing the hour as an hour to save a step, an hour is 3,600 seconds. So I have 1 mile per 6 minutes, and then I have 60 minutes in 3,600 seconds. And then, so that gets rid of my minutes. I'm trying to calculate or get rid of my units. So I have miles canceling, minutes canceling. And now if I think about the conversion between a calorie and a joule, there are 4,184 joules in 1 calorie. So that gets my calories to cancel top and bottom. And that means that only my joules and my seconds haven't canceled. So I'm in joules per second, which is a watt. I didn't do the math there. You can just plug it into your calculator. So Jocelyn, here's the last one. They asked you to convert the density of styrofoam from ounces per cubic inch into grams per cubic centimeter. So the first thing I did was I took the amount they gave me, or the density they gave me, 0.03 ounces in a cubic inch, and then I converted ounces to grams. And I just looked that conversion up. There's 28.35 grams in an ounce. So now my ounces, oops, I have to cross that out with a slash. So ounces are gone, and I'm in grams per cubic inch, but I need to get to grams per cubic centimeter. So I have to convert my inches to centimeters. So I know in 1 inch there's 2.54 centimeters, but I have to do that 3 times because, again, I have cubic inches, and I have to get to cubic centimeters. So I just do it 3 times in a row, the same conversion. Your teacher in class might just do this. They might just write it 1 time, 1 inch over 2.54 centimeters, and then close the parenthesis and put a 3 above it. It's essentially the same thing. So you can cube 2.54 in your calculator, and then that's going to be on the bottom. So you're going to multiply 0.03 times 28.35, and then you're going to divide it by 2.54 to the third. And then they ask you if it will float in water. Well, the density of water is 1 gram per cubic centimeter. So if yours is less dense than water, if it comes out less than 1, then it will float. But if it comes out greater than 1, it's more dense than the water, then it will sink. So I hope that helps. Come see me in my classroom if you need more help.